Good morning all. Here's a KEB F4 and its material number is 07F4F1D-4A03. We're going to go inside and see what our problem is. The customer complained that this drive is acting strange. I don't know what that means, but let's go inside. To get this cover plate off, we squeeze these two walls together and that cover plate will come right off. It's hinged here at the back in these two holes right there. Now let's undo these two screws that hold the main cover together. Get a little cup to put those screws in. That will loosen up the front end. But what we have to do now is undo these two plastic clips. To do that, take your screwdriver, sit down in there, try not to break that plastic, and just give it a little bit of a push there. And that one side hopefully will come off. Now let's do the other side. Oh, that one went back in. Huh. I wonder why this one is being so hard to come out. Come on now. There we go. We got that one side undone. They're usually not this ornery. There we go. We got both sides undone. There's a hook right here and a hook right here that hooks into the grill of that cover. Now we're undone. Get some pictures. Let's take a look inside. Okay. I see all original caps, and look here. The current sense modules are scorched, so they're going to have to get replaced. We're going to have to replace the capacitors on the power board. They're looking a little discolored. So up here's the feedback and power supply board. We're going to recap that, and down here is the power board. Now one of the problems with working on these drives is that the IGBTs are brought up through the bottom of this plastic housing and soldered to the power board. So in order to get the power board separated from the IGBTs in the plastic housing, we have to unsolder all of those IGBTs, and then we have to unsolder the three-phase bridge over here on this side, and it is a bear. It is a grizzly bear. I have to order a whole new box of cuss words whenever I work on one of these drives. They're very difficult to get apart. But I've done it before, and we're going to do it again this time. Let's move these covers out of the way. Got to undo the ground wire from the heat sink. There we go. Now it'll come off. Okay. Oh yeah, look at that. Can y'all see that? That capacitor has bulged out on the top right there. So all of these caps right here are going to get replaced. The only ones I don't replace because they're such a hard time to get off the board are these 4 surface mount caps. I leave those alone and I change out the electrolytic capacitors, the through hole ones. Now let's go take a look at the power board. There's the cooling fan wire. Can you see this capacitor right here? That should be a bright blue capacitor, and it is turned darker in color because of overheating. So that one's going to get replaced. And then there's 2 capacitors down here. This one and right down there in the corner, if I can stay in the frame, there's another capacitor that's going to get replaced. But in order to do so, we have to separate the power board from this plastic housing. Another thing we're going to do, you see the side of the current sense module, how it's scorched? That one has to be replaced. And this one has to be replaced. Both these have gone bad. And here are the new ones. And their part number is HX10-P. Oh, here's the part I dread. Okay, let me get the fan out of the way. And we're going to unsolder the current sense board, the IGBTs, the 3-phase bridge to separate that power board from its mount. Let's get the cooling fan disconnected and moved out of the way. Right here's the 24 volts DC for the cooling fan. Come on. That one's tight. Usually just pull right off, but sometimes they don't. Let's see if I can lift it up this way. Come on. Ah, there we go. Okay. Get our wire undone. We got 2 screws right here that have to come off that mount that plastic and cooling fan together. So we're going to undo those. They're long screws. They have to be to go through the plastic and the cooling fan. There you go. Get my wires tangled up there. There you go. Now we're going to test this cooling fan before we install it. Make sure it's okay. Set that over there. Now, what I do is I take a solder sucker, heat up these pins and suck the solder out and get as much solder off that I can, and then I'll take magic solder, stays molten for a very long time. Here it is right here. It's called Chip Quick. Y'all see that? Chip Quick. Now this it's solder, but it stays molten for a very, very long time, and it allows you to remove surface mount parts. But I've found that I can remove stubborn parts also. And these parts right here, they're very stubborn. And that three-phase bridge, shoo-wee. Okay. So, we'll start with the IGBTs. All right. Let's get the current sense board out of the way. Got to be careful here because we have plastic all around us. We don't want to melt the terminal board. So I'm going to add a little bit of solder to help the old solder flow. Always being aware of where my iron is so I don't melt that terminal board. I'm not worried about those current sense modules, they're bad. So they do not matter. But that terminal board up here, I don't want to melt that. There you go. There's our current sense board. Let's set that over there. Now, pull this out because there's a screw underneath this standoff right here. You'll be wondering why you can't get your board apart. It's because that standoff has a screw behind it. Come on. There we go. Yeah, broke it, but that's okay. We'll still be able to use it. Let's put that in our parts bucket. There's a screw out here we want to take out. Set that in the parts bucket. Now, underneath here are 3 screws. One that was below the standoff. Then there's 2 on each side of the ribbon connector that press a metal plate down onto the IGBTs so that they have good heat sink connection. You have to be careful of this hybrid module right here because you can crack it. If you crack that, you're done. So what I do is I have this little screwdriver right here, and it's that little because I can't get my standard screwdrivers down through the hole in the board. So I got this one here, and I take a pair of pliers, and I want to be high enough so I don't plow into this hybrid module and break it. So put that right there and use your pliers to break that screw free. can't get no torque without those pliers to get that screw loose. They're always very tight. And if you don't have the pliers to give you that extra leverage, there. Okay. Let that one run up. There's that one. There's that one. Oh, we did good. We didn't break that hybrid module. Okay. Now, there's also there we go. There's also a screw that holds the three-phase bridge to the heat sink assembly. So you want to loosen that one up. They're not backed out all the way yet, but almost. Here we go. Now, the blue caps are probably going to get in the way of you watching me unsolder those IGBTs. Here we go. I'm going to get as much of the solder off as you possibly can. Almost there. Now, right here is a thermal that butts down onto the heat sink assembly. And it's got 4 pins that we need to unsolder. we got as much solder as we could off of the IGBTs. Now we're going to move over here to the three-phase bridge and do the same thing. I'm going to go over here and turn my fan on and blow this solder smoke out of my face. I'll be right back. Again, I'm adding solder to help the old solder flow up into the solder sucker. Trying to be careful not to melt that plastic housing. Take our solder wick, try to wick up as much as that solder as possible. Stop sliding around, hold still, We're trying to fix you. Okay. Now underneath, there's 4 screws that hold the plastic to the heatsink assembly. We have to undo those 4 screws. Hopefully the plastic will hold up. That plastic gets brittle from heat. These screws never want to come out without giving you fits. Okay, come here, magnet. I need my magnet. Let's put that 1 screw there. Second screw. Number 3 of 4, last one. Now that we have those 4 screws removed, we can back these screws out. There we go. Capacitor that sits down here that we we have to undo. I'll show you that capacitor. Let's set our heat sink over here. Come on. I got too much plastic around it. Trying not to melt anything. Okay, that's free now. Flip this on the other side and you can see the IGBTs. Here's the IGBTs. Here's the thermal. Here's the three-phase bridge. Now these 6 IGBTs are to run the motor, UV and W. This last one here, am I going right? Nope. 1, 2, 3, 4, 5, 6 are to run the motor, UV and W. This one here is for the regenerative braking circuit. Let's see if we can get those IGBTs off there. Wick out the excess solder that the solder sucker did not pick up. This takes a while. You gotta have patience for this kind of work. Especially when you get something like this that was never intended to come back apart when they put it together at the factory. But you know, that never stopped us. Never stopped us, has it? We'll try to go into anything to fix it. Get that wire out of the way. Okay, let's go to the thermal. You know, I'd like to know, just out of curiosity, what's the hardest thing y'all have ever had to take apart to repair? I'd be really interested in knowing. I'd have to say that the hardest thing I've ever had to take apart to repair was this KEB F4 right here in front of us. I've had some other things that were hard to take apart too. And a very large Lindsay drive. It must have had, oh, I don't know, it must have had, before I got to the bottom where the power devices were, it must have had 200 parts come out of it before I got there. Screws and bolts and nuts and boards and all kinds of stuff to come out of there before I got to the bottom. What's kind of weird too is that the parts you have to take and replace are always on the bottom. Never on top of the drive. Seems that whenever I'm doing any kind of repairs, I'm always heading toward the bottom of the drive. Okay. I got as much of the solder out of the way, I think. And now what I'm going to do is I'm going to push the pin of the IGBT away from the via. You hear it popping away from the wall of the via? I think a couple fell out on their own. No, not yet. Trying not to melt these blue capacitors either. Everything is just right up against where I'm trying not to burn. There's one fell out on its own. There you go. I'll tell you the part number. It's BUP 313D. They're all the same part number. Set that over there. It's nice. I didn't have to use the magic solder on that one. It just came right out. There's another one. Came out right beside it. Let's put that over there with its friend. Let's undo the thermal. Okay. Let's see if we can get that thermal out. Push on the pins on this side so we can try to pluck it out from that side. Alright, there we go. That fell right out. There's what the thermal looks like. Now on the long side, these two long outside pins, I have 1 kilo ohm, and then these two side-by-side pins, there's a thermal switch. It would measure 0 ohms. We'll set that right there. There's one. Part number BUP 313D. That one, that's the one for the regenerative braking circuit. Set those right there. Two more to come out. Last one. might be a little bit difficult to get out. Yeah. Come on. Come on. You're almost there. Don't fight us. Come on. Must be a little bit of solder on the end there. There we go. We got it. So now all 7 of the IGBTs have been removed and the thermal. I'm going to take a little bit of a break. I'll be back in just a little bit. Now, I have to use chips quick on that 3-phase bridge. It is just too difficult to get all the solder off of that board right there. So, chip quick is the method. And here's the mounting screw, mounts it to the heat sink. So what I'll do is I'll flow the chips quick on there, continue to apply heat while I'm pulling on this screw. Let's add some flux. And now we'll add the chip quick. Turn this on the side. There we go. Let's apply the heat. Here it's starting to loosen up. I see the pins moving on the board. There we go. That chip quick is amazing. I couldn't have done that without the chip quick. There's our 3-phase bridge made by IXIS. It's part number VUO25-16 N08. Set that over there. And we are free of the plastic housing. Back side of the board looks real good. I'll set that over there for a little bit. I'll show you the 3 mounting screws that compress the IGBTs to the heat sink, so we have good heat transfer. Set our piece of cardboard back on there. That cardboard keeps that metal from touching the bottom of the power board. Here is that little capacitor That connects frame ground of the board. Come on, I'm all bent up in here. Connects frame ground of the board to the heat sink. So it's just a little coupling capacitor to couple the grounds. Set that over there. I gotta fix this. You can see from heat the plastic becomes brittle and cracks, so I'm going to put some super glue on there. Let me do that first. Let this dry, let that super glue dry.